Well, hello everyone. Happy Mother's Day to everyone. I'm hoping you guys are doing well. Maybe having a little time with mom. Maybe this is a sad moment for some, but here's my thing. We're here. We're growing. We're getting things done. I'm so happy that you were here. So, today I am actually, hi everyone, look at you guys flowing in here. So today we're actually going to be looking at what's called special triangles. Now, special triangles are used when you have 90 degrees or right triangles. So there's like certain formulas that if you are given, and I noticed that in some assessments, they do have mostly what's called a 30, 60, 90 degree triangle. And sometimes they'll throw in a 45, 45, 90, but for most assessments like the ASVAB, ACCUPLACER, GED, and if in class, but mostly those assessments, they always kind of give us a 30, 60, 90 triangle. And if you knew this whole complex, not really complex, but a compilation of how to do this, it will save you so much time and so much energy. All right, so let's get started. So let me zoom in a little bit so you can take a look. Now, when you're dealing with 30, 60, 90 degree triangles, because remember, triangles, the sum of its angles equals 180 degrees. So when we're given a 30 degree angle, so here's 30 degrees, the side that's opposite that 30 degree angle, that's your smallest side, okay? Okay, so you have your 30 degrees, opposite that, that's going to be your smallest side. So we're going to call that X. Now, the side that's directly across your, sorry, I thought I had like a brain fart. Sorry. So the side that's directly across from your, what is it? Hypotenuse. There we go. Can you tell I've been doing so much today? All right. So the side directly across from a 90 degree angle, that's your hypotenuse. Now for a 30, 60, 90 degree triangle, this is always going to be twice as big as your smallest side. Okay. All right. So it's always going to be twice as big as your smallest side. Now, the side that's directly across from your 60 degree angle, that's your other leg. Okay, remember, these are your two legs. This is your hypotenuse. So your other leg is really simple and easy. It's your smallest side being multiplied by the square root of 3. It works each and every time. Yes, C4. There you go. It's a Carletta. How are you? Hello, hello. Okay. Oh, well, thank you, Daily Reminder. I appreciate that. Yes, right back at you. Sure, not a problem. So when you have your 30, 60, 90 degree right triangle, okay, the side that's directly across from your 30 degrees is always your smallest side. The side that's directly across from your 90 degree, which is your hypotenuse, which I was struggling with the word earlier, is twice as big as your smallest side. And the side that's directly across from your 60 degree angle is basically your smallest side being multiplied by the square root of 3. Now, the easiest way for me to think about this is when I think of 30, 60, and 90, they're basically multiples of 30 or 3. So since I'm thinking about the multiples of 3, that's why I'm going to have my square root of 3. Okay? Since 3, 6, 9, I think of multiples of 3. That's why the middle term will have that square root of 3. All right? Isn't the shortest side the hypotenuse divided by 2? So we have the shortest side. Yeah. The same thing as saying the hypotenuse is twice as big as the shortest side. Same thing, user. Or Victor. Same thing. Okay? So, let's do a little bit of work. Okay? So, keeping that in mind. So, right now, I'm just going to do 30, 60, 90. And then I'm going to shoot down to the 45, 45, 90. All right? So, if we take a look, zoom in to our 30 degree, our 60 degree, and we have our 90 degree, okay? Now, I'm given the side that's directly across from that 30 degrees. So we can say X, or this 8 is my X, my unknown side. We know the side directly across from the 60 degrees is going to be your X times the square root of 3. And the side that is your hypotenuse, remember your hypotenuse is always opposite that 90-degree angle. That's going to be twice your smallest side. So they gave us the smallest side. Okay, the smallest side is going to be 8. So I know the easiest thing for me to do is think of the hypotenuse, because the hypotenuse is going to be twice this. So 2x is actually going to be 16. Sorry, I had a pen cap in my mouth. So we had our 16. Okay, so we got 8 times 2. That would give us our 16. All right. So now we need to get the side that's directly across my 60-degree angle. And they're saying that it's your smallest side times the square root of 3. Well, if my smallest side is 8, and then we attach the square root of 3. And that's your answers. That's it. Okay? Nothing too crazy. Nothing all kinds of wackadoo. Now, if your teacher wants it in decimal form for some reason, sure, then let's put it in decimal form. So, handy dandy calculator. Okay, so you have your 8 times the square root of 3. And then you can round it. So you have 13.856400646. Okay? Say they want it rounded to the 1,000th position. Gotta emphasize the TH. So what's in the 1,000th position is 6. So in order for me to round, I need to look at the previous number. If it's a 5 and above, we're going to give it a shove. That means we're going to add 1 to that 6. And then we're going to knock out the rest. But if it's 4 and below, we're going to leave this 6 alone. And then we're going to remove anything after the 6. So your answer rounded, if we do want that 8 square root of 3, will be 13.856 if you round it to the 1,000th position. But I'm going to be truthful. Majority of the time, when they want the unknown side, they're going to want you to keep it as 8 radical 3. Okay. Yeah. C4, it could be 13.86 if you're rounding to the 100th position. If you round it to the 1,000th, you got to take 1 to 2 digits over. Okay. All right. Okay. Awesome. So if you stay with the 100th, yes, that would be your correct answer. All right. So now let's shift over. Okay. So taking a look, and I think I already explained it a little bit, but I think some people are coming in or maybe going out. All right. Awesome. So we all know that that side that's directly across from the 30 degrees is my X. The side that's directly across from 90 is my 2X. So that means the side that's directly across from my 60 is going to be my X square root of 3. I just want to emphasize that. All right. Well, what happens if we have this one? What will be my x? What will be my x? And we're just looking at this one right here. Hey, Amber. So far, so good. So far, so good. All right, so C4 is saying 10, Pog is saying 10, C4 is saying 10 radical 3. Which one, C4? Q1, okay, 10. I was like, Q. Okay, so we're saying sine is opposite the hypotenuse. True, but we're looking at the length of the sides. Okay, G-Man saying 30. Oh, you did both of them. Okay, gotcha. Because some people like to change their answers, and I was like, why did you change it? All right, so we got 10. Is it Shamira? Got 10 root 3. Jacob saying 10. Okay, Jackson with the 10. Thank you. Thank you, Cheryl. All right. And then 10 root 2, not root 2. Okay, this is a 30, 60, 90 degree angle. So, since x is the side directly across from 30 degrees, okay, that means this is going to be my smallest side. So we know the hypotenuse, which is 20. 20, as we keep saying, is 2 times the smallest side. So as Victor mentioned earlier, if we take 1/2 of the hypotenuse, we will get our smallest side, which gives us 10. So now C4 is telling us that 60 degree, which is right here, and the side directly across from it is going to be your smallest side, which is 10 square root of 3. Okay, good. Really, dude? Where was I? I was here. I don't know. I just don't know when I'm needed. Yes. Okay, I can't even remember how to do square roots. That's all right, deuces. Well, welcome in. Just use sine rule. Well, why use sine rule if you can know special triangles? Because we were still working out. You do algebra 2 too? Yep, I do. Algebra 2 is my jam. All right. I learned it just now. Okay. All right. Now, try this one. Okay. Try this one. You'll be here next year? All right, cool. I'll be here. God willing, yeah. Not really. This is like geometry. Because special triangles is so much easier. What are we solving for? My unknown sides. What do you think my unknown sides will be? Can you do trig? I'm struggling with it. So like what part of trig? Pink heart. Hey, April. Hey, Ellie. You have a geo exam next week. How do you do this? How do I do this? Okay. Well, we'll show you. Equals 24. 6 root 108. How do you solve this? Okay, we're gonna come. I just want to see what you guys can do. I forgot. Okay, no problem. Laws of sines. We can do that. Use the 30-60 rule. Yep, that's what we're working on. 30-60-90 triangles. You're intrigued? Good. Not a problem. No, we don't really have to use sine, guys. We can. We don't have to use the sine or cosine. All right. Okay, the little square is 90 degrees. Yes. So Doug is saying 9 and 15. Hello, Doug. Lisa, how are you? Okay, short side is 6. The hypotenuse is the square root of 108. Okay. Interesting. Okay. Yeah, we're doing, that's exactly right, Jess. 30-60-90 triangle rule. There we go. Okay. So Fresh is saying 180. Oh, yes. Happy Mother's Day to you, too. Okay. All right. Let's see if we can work this out. So, as I mentioned, the side that's opposite the 30-degree angle is our smallest side. The side that's opposite the 60-degree angle is your x equals, or your smallest side, times the square root of 3. The side that's directly your hypotenuse is always twice the smallest side. So what's kind of missing here is we don't know exactly what is the smallest side. But we know that the side that's opposite our 60-degree angle is 12. And based off of the 30-60-90 rule, the side that is normally across the 60 degrees, it's always your x times the square root of 3. But right now, 12 is taking that place. So what we could do is to use this information to find our smallest side. We already know the middle side, so let's see if we can find the smallest side. So if I divide both sides by the square root of 3, I can get x equals 12 over the square root of 3. But we all know we should not, it's not that we can't, but we should not have a radical in our denominator. So how do we do that? We rationalize it. So that means we have the square root of 3 over the square root of 3. Square root of 3 times the square root of 3, what would that give me? Okay, it will give us 3. Good, C4. I know a lot of people would say square root of 9, which is true, but the square root of 9 gives us the whole number of 3 because it's a perfect square root. Now in your numerator, you're going to have 12 square root of 3. What do you notice? This is geometry, Sam. Yep. What do you notice? Okay. Not matching 3's. The 3's can't cancel. Stop. The reason why this square root of 3 and this whole number of 3, two separate worlds. Okay? This is an irrational number. This is a rational number. So we can't touch the 3's. But what could we touch? Lisa, you have that answer. How did you get that? Yes, we can divide. And yes, the phantom. Hello. Yes, we can divide the 12 and the 3. Both of them are rational numbers. Yep. I think so, real dude. I think so. We might do something else, but it all depends. So 12 divided by 3, that gives me 4. And then that square root of 3 comes on down. So what we found is x. And x is the side that is directly across from our smallest angle, which is the 30. So we found that this angle right here is going to be 4 the square root of 3. I tried, Lisa. Yes, good job, C4. Okay. All right. So someone asked, I wish I could scroll back. There's a lot of stuff going on. Someone asked, why do I use x to square root of 3? Now, for the 30, 60, 90 degrees rule, the side that's opposite your 60-degree angle is always going to be x times the square root of 3. The side that's across from your smallest angle is going to be your x, which we just found. And then your side that's directly across from the 90 degrees, which is your hypotenuse, is always twice the size as your smallest. So we found the smallest, which is 4 square root of 3. Now we need the hypotenuse. Okay? The rule is called the 30, 60, 90 degree rule. Okay? Yep. So shorter side, medium side, hypotenuse. So basically you have your two legs, Nina. Okay? So these two, they're called legs. So you have your two legs, and then you have your hypotenuse. Your hypotenuse is going to be twice the amount of your smallest side. So that means we need to go 4 square root of 3 times 2. What would that give me? Advanced algebra? Not really. Okay, so it's not advanced algebra. It's like really stemmed into geometry. Advanced Pythagorean theorem? Meh. There we go. All right, good, Nicole. There you go. Hello, Michael. All right. Meh. All right, yes. So, well, deuces, it's okay. We're going to break things down here. You should know me by now, okay? So, we're doing the distributive property. You can multiply whole numbers with whole numbers and radicals with radicals. So all we're doing is multiplying 2 times the 4, which gives us the 8. And then we bring its radical 3. That's it. Yes. Yeah. So we don't have to do that. We're not multiplying the two legs. Because if you really think about it, just like what Lisa was saying, this is a Pythagorean theorem, okay? If you want to, I'll show you, because I like to show options. So if this is too much for you, you're like, oh my God, when is this lady going to do the next one? Well, this is probably not the platform for you, okay? It's all right, because I like to take things step by step. So we have our a squared plus our b squared equals our c squared. That's that Pythagorean theorem. All right, so if you're unsure, we got the handy dandy right here. Okay, Pythagorean's theorem. Some people like to say c squared equals a squared plus b squared. Meh, come see, come sa. All right, but no matter what, your c squared is, that's your hypotenuse, and a and b are your legs. They're interchangeable. So if we were looking for, let's say, the hypotenuse, and we know that one of the legs is 12 squared, and the other leg is 4 times the square root of 3, and we're going to square that. And we were looking for that unknown side, which was our hypotenuse. Okay, let's say we wanted to do the Pythagorean theorem to find the hypotenuse. 12 squared, 12 times 12, gives me 144. Now, 4 square root of 3, remember, you're squaring everything inside of this parenthesis. That means you're squaring the 4, which gives me a 16. And you're squaring the square root of 3. Remember, squares and square roots, they're opposites of each other. So that gives me 3. So now our 16 times 3, well, that gives me 48. And we're going to add that 144. And I think this is why somebody was giving me like 100 and something for our answers. So we got 192 c squared. So now we need to figure out the square root of 192. So you're like, all right, well, 192, that's not a perfect square. Well, if you had my handy dandy notebook, we can come right in and take a look at 192. Let's see what will work for us. So we have factors. We have 1 and 192. We got 2 and 96. We got 3 and 64, 4 and 48, 6 and 32, 8 and 24, 12 and 16. But your best perfect prime combination will be 3 and 64. Because 64 is a perfect square. Square root of 64 gives me 8. And the square root of 3, since that's prime, that just comes down. And I know normally we would do plus or minus, but since we're looking at a length of a triangle, we're only going to be using the positive. Now, you can do all of this loveliness, or you can remember your rule, okay? The side opposite 30 degrees is the smallest side. The side opposite your hypotenuse is twice your smallest side. And the side in the middle is your smallest side times the square root of 3. All right. Okay. You need that sheet? Hey, you can go to my website and you can order your book. Okay. I have the whole entire book, this whole thing. You can go to Amazon. You can just type in my name, Audrey Codner, or you can go to my website and click on the Ultimate Math Notebook. And you can just click the link for the 7th through adults. And that will be there for you. All right, let's see. What about the angle of elevation and depression? What about the angles of elevation and depression? We're not working on angles of elevation and depression. I know, Morrison, you're trying. It's so sweet. You're trying. Okay, website, yes. So click on my picture. It's on my profile. It's definitely on my profile. Okay. All right. Thank you, Lisa. So simple, right? Like once you get the right tools, we'll be able to break it on down. Now, remember, this only works with those right triangles. That gives you a 30, 60, 90 degrees. Oh, really? Oh, Lisa, there's such a world. There is such a world out there. But now we're going to work on the other special triangle, the 45, 45, 90. So what type of triangle will give me two sides that are the same? What type of triangle? What do we got? When two sides are the same. Yes, Michael R. There you go. ISO, yes. Okay. We do have a right triangle. but it's a special right triangle. Sorry, I'm not doing any battling. Yes, bundles of blessing. Hello. Gen X Todd, love that. All right, so it's a isosceles right triangle. Okay, so when the base angles are the same, that means their opposite sides are also going to be the same lengths. And then you have your 90-degree angle. Remember, the side opposite the 90-degree angle is your hypotenuse. All right, so to best remember this, two of the sides are the same. So that means in order for me to get my hypotenuse, I take the length of one of the sides and I multiply it by the square root of 2. All right, so two sides are the same, square root of 2. Sides are multiples of 3, square root of 3. Okay, that's the only way that I can remember it to this day. All right, okay, so taking a look, as soon as we get nice and clear. All right. They always throw one of these questions in. Yes, you can. You can call it that for short, of course. So they always give you basically tick marks. These tick marks means that these four sides are exactly the same. Okay, so if all four sides are exactly the same, and those little boxes means 90 degrees. So if all four sides are exactly the same, and I'm given 4 right angles, that means this whole entire thing is a square. And I know you're going to be like, Audrey, I have 2 eyes. I can see that it is a square. But the one thing about geometry that you have to remember is you cannot believe your eyes, because there's going to be times they're going to say something like not drawn to scale. They always put that in all SATs. So you're like, oh yeah, this is a rectangle. And then all of a sudden the answer is like, no, it was a parabola. And you're like, what? Or you're like, that doesn't look like a parabola. Exactly. They do not go by sight. You always have to prove that it is a certain shape. That's the one thing about geometry that's really interesting. Like every time you're trying to prove your point, you have to put all the facts in. You can't just say, well, it's because that's what I heard. No, you need to prove your point. So that's why doing an argument, that's math. You have to take all the little bits of details, and then you have to figure out what was true, what was first person, what was second person saying, what was the true facts, so you can come up with your proper conclusion. All right, so have you ever heard of a conditional statement, like if-then statements? If this, then that, like if I'm relaxing at a beach, then it's Sunday. If it's Sunday, then I'm relaxing on the beach. Okay, that's math. Okay, they're called conditional statements. All right, so is the equation for this 10x 0.707, or is 5 radical 2 correct? All right, we're thinking, which is great. So we are basically going to pull this information out. This is going to be your parabola. No, sorry. Hypotenuse. Sorry, I just wanted to get a piece of paper. So if I cover this up, look at it as a triangle. All right. So like I mentioned, your longest side is equivalent to 2 the square root of 2. So if we're saying that x, the square root of 2, is equal to 10, we can take the square root of 2 on both sides because we're trying to isolate the x. But we don't like having a radical in the denominator, so we got to rationalize it. So when you rationalize it, that means you're going to multiply the numerator and the denominator by that radical 2. Okay? So now you're going to have, and I'm going to put it down here, give myself some room, 10 the square root of 2 over square root of 2 times square root of 2 gives me square root of 4. But the square root of 4 is a perfect square root, which gives me a whole number of 2. Okay? So it's similar to what C4 was saying. We're kind of getting there. All right? So now, what can I do next? What can I do next? Okay, what do I... Yep. And then you change your answers. Don't change your answer. Okay. Yes, divide. Yes, so we want to divide the 10 and the 2, which gives me 5. And then that square root of 2 that we had in the numerator just comes on down. So what we found, because this is my x equals, what we found was the length of one of the sides. But since both sides are congruent, they're the same length, that means both sides are 5 square root of 2. I'll put it over here. Okay. Okay, good. Yes, G. Boston. Yes, we're doing both. Good. Good. Nice. There we go. All right. Questions so far? So I'm basically using my rule to help find the length of the 2 other sides. Okay. So instead of looking at it as one big square, cover up one side, or maybe even, completely redraw it off to the side, and then use your rule to figure out the length of one side. Of course, I got you, love. If we do not know they were congruent, would you use Pythagorean theorem? Now, here's the question. You only know the length of one side. So since you only know the length of one side, but by the indication of the tick marks, because if this is 90, I know half is going to be 45. So we could possibly use like sine or cosine, law of sines or law of cosines, to help find the other sides. Okay. The square root get divided by 2. Oh, good question, Shovel. Okay. The reason why square root of 2 is an irrational number. The whole number of 2 is a rational number. These are 2 separate worlds. They can get close, but they can't mingle. Okay? So just because there's 2's, this is a square root of 2, that's a different value than the whole number of 2. All right? Okay. Try this one. Sure, P. Okay. If they give you a 30 degree, if they give you first a 90 degree angle, okay, so they give you the little box, and then they give you another angle that says 30, that's when you're going to do the 30, 60, 90 degrees. But if they give you, like say like this example, they give you a 90 degree angle, and then the other 2 angles are 45s, that's where you're going to do 45, 45, 90. Okay. So they're usually going to give you something more than just the square root. Okay. You're welcome. Okay. It's probably not wrong. Okay. On the other one? Todd, what do you mean on the other one? On the last problem that we just did? Okay. So I'm seeing 9 radical 2. Okay, on the other one. No, that was right. If you wanted the decimal form, Todd, that was right. All right. Okay, we used the constant of points. Yeah, last one. Yep, that's right. Because 5 times the square root of 2 gives me like 7.01. No, 7.0710 something. 6, I think. All right, I'm trying to pass the GED math test, but I have a difficult time. Oh, what's going on? What's happening? Is it feeling like test anxiety? Or is just like, I just don't know where to start? Okay. Now, they gave us, again, the hypotenuse. And we know the hypotenuse is x the square root of 2, and it equaled 18. First thing we did was divide both sides by square root of 2. But we can't have a square root in our denominator, so that means we multiplied the numerator and the denominator by the square root of 2. Oops. So that gave us 18 square root of 2 over 2, because remember, square root of 2 times square root of 2 will give me square root of 4, but the square root of 4 will give me 2. Shortcut, if you're multiplying the same radicals with the same radicand, that's what underneath the radical means, it will simply give you what's under the radicand without the square root signs. And simplify here. This is going to be a 9. This is going to be a 1. So you got an answer of 9 square root of 2. And that's what your x, or unknown side, is going to equal. Has anyone figured out another pattern when given the hypotenuse to find the other two sides of a 45, 90 degree angle? Has anyone seen a pattern? A radicand? Gavin, you're cracking me up. The radicand, what the heck? It's a radicand. It's like, is that what I put my ketchup in, the dip in, the chips? What the 2, okay, the number that's underneath the square root sign. The square root sign is also called a radical. What's underneath that radical is a radicand. Okay, not denominator, the radicand. So what's underneath the square root sign? That's called a radicand. Ooh, C4, yes. Pog, yes. Okay, good. If you are given the hypotenuse and you divide it by 2 and then multiply the square root of 2. Divide 18 by 2, that will give you 9. And then we put on the square root of 2. Same thing happened for the previous one. We had 10. 10 divided by 2 gives us 5. and we got a square root of 2. Okay. Will that happen every time? Yes, it will. So if they give you the hypotenuse, you can, and it's a 45, 45, 90 degree angle, you can take half of your hypotenuse and multiply by the square root of 2. It will work each and every time. Right? Oh, no problem. The name of the symbol, though. All right, now you know. There we go. I feel like it should have like the little star that says "the more you know." Okay, I would use trig. True. Yep, and you can use trig. Is this the same rule for 30, 60, 90 triangles too? Now, for the 45, 45, 90, since 2 of your base angles are the same, 2 of the sides are going to be the same. But the only thing is your hypotenuse. Okay, Liv, your hypotenuse is going to be your smallest side, which is x, times the square root of 2. So that's what's different. Okay. Hello, creation. Thank you for sharing, Jocelyn. I appreciate it. Got my dad's phone. Okay. Yes, Todd. I knew someone. I was waiting. I was like, I know someone understands what I'm talking about. Not a problem. All right. Now, let's try this one. Okay. Let's try this one. And this is still, let me put this in here. 45, 45. Okay. Okay. What are we doing? We are using perfect triangles. The 40 right now we're doing 45, 45, 90. Yeah. So 30, 60, 90, different side lengths, different ratios. Okay. Okay, tell me what the value of x and y is. Hello, Desert Bear. How are you? Hello, Nico. All right. So the 18 root 2, is that for x or for y? Okay, so Gavin's saying 18 and 9 root 2. Okay. For y, you are correct. Good job, Nico. Okay, Bree, yes. Bree, yes. All right. No problem. All right. So this one wasn't too crazy. Okay. We know that we have, why is everyone in like, everywhere wants to talk to me. All right. So we have our 45, 45. So we know that the side that's opposite this 45 is 18. So that means this one's going to be exactly the same, which is 18. And since we know it's a 45, 45, 90 degree angle, we know that this, my longest side, is going to be the 18, but all we're doing is multiplying the square root of 2. Okay, good. All right, let's try one more. And I'm not going to say a word for like 1 minute and 15 seconds. This is like geometry. Okay, 10 more seconds. All right. I know, it made a lot of people paranoid. She's not saying anything. It's getting crazy. Jasmine, I'll explain in a moment because that's definitely a handful of questions. All right, so we definitely had some answers. I know, I usually like to give a pause. So C4 said 3 square root of 2. Daniel said 3 root of 2. Bundles of blessings said 3 root of 2. Daniel said 3 root of 2 again. Then we have Sham. This is 3 raised to the second power. We had, Michael, you said something too. Michael, you had your 2. We had, oh wait, everything's flipping around. JBD said 3 root of 2. Sham said 3 root of 2. In case you made corrections. Good. Rio said 3 root of 2. Michael was nervous. Then we had square root of 18. 3 root of 2 will live. Okay. Wonder if you messed up. Jasmine, I'm going to come back to your questions. C4, 3 root of 2. I know, you guys don't like when I'm silent. Makes you paranoid, don't it? All right. So they gave us 2 sides. Same tick marks. So that's indicating that these 2 sides are the same. Okay. So since I have a 90-degree angle, that means these other 2 angles, the sum of them have to equal 90. And the only ones for them to have the same base angles is going to be our 45 degree angles. Okay. So like we said, if the hypotenuse is 6, we can take half of that and then tack on the square root of 2. So half of 6 is 3. So that means we have the 3 root of 2. So just by knowing the special triangles and you're given this problem, this will be kind of considered like a medium problem for a GED, a medium problem even for the ASVAB. So they might sneak this in. I know GED, they'll probably sneak this in. ASVAB, they might put a problem similar to this. It might be like a word problem that you have to pull all the stops out. But by knowing what a 45, 45, 90, as well as the 30, 60, 90, you can save so much time and so much energy. And then you can spend all that extra time that you didn't spend on these problems with other problems and take it and run with it. Now, it does rather than silence is frightening. I'm sorry, but I really want you to see that a minute 15 for most of the exams, GED will give you a little bit more. I think they give you like 2 minutes and 10 seconds, really, per question. And if you understand that once you understand and answer one of the questions in like, 15 seconds, you can take that excess time to put it in one of those harder questions. Okay, so I just like you to see all of that. Sorry for that. All right, Jasmine, I'm sorry. I know. It's like, it's awful. Do not like you. Aw, why do you not like me? Because the trig? We're going to break all this down. Okay. Like that better than trig? Okay. Now, I think sometimes a lot of people are good with SOHCAHTOA and they're good with Pythagorean's theorem. But then once you start throwing in the sine waves and the cosine waves and some of the tangent waves and knowing your amplitude and your periods and all that shifting, and yeah, it gets to be a bit much. So to answer your question, where is the question? Okay, so I know in Maryland, they're actually putting a proposal to basically get rid of Algebra 1, Algebra 2, and make it into Math 1, Math 2. And then give the students an option of doing some kind of extension math for the third and fourth year of high school. Reason why they're doing it is they're feeling like there is a lot of repeat and cutting. So what they're thinking of, this is their whole mastermind. Am I saying I agree with it? Not really, especially the way that they're thinking about it. So they're thinking about doing parts of Algebra 1 mixed in with geometry, a little bit of geometry, and mixed with a little bit of statistics. So they're going to have a mixture of that first year, and then they're thinking about doing a mixture of that the second year. And then if students want to dive in deeper, like say pre-calculus or calculus, that works all hunky-dory and fine. But here's the problem. That works great for students that are on track to basically take the SATs as sophomores. So if you know, the SATs go up to Algebra 2. So if you got these kids taking, Algebra 2 their freshman year, and then you could just revisit some stuff their sophomore year in time for them to take the SATs, this is all funky-dory and great. But there are a lot of students that are not taking Algebra 1 until their freshman year of high school. So a lot of them go Algebra 1, Geometry, Algebra 2. So those kids that are taking Algebra 2 their junior year are considered slightly behind. And of course, that's when colleges want to get all your information. Now, here's the fun thing. When it comes to scholarships and everything, that's your PSATs. But this is now things have improved from this, because now they have PSATs where there's a special one for ninth graders, because they finally realized that, oh, wait, our ninth graders and sophomores are not learning Algebra 2 until they're juniors. So maybe we should test them on something that they're currently learning. I know, it took them several years for them to do that. But yeah, they're thinking it's refining it. It's really speeding it. It's speeding up the process. It's speeding up the curriculum. They can sit there and say they're not speeding things up, but they are. After the pandemic, everything got sped up. The kids, when they went back to school, there wasn't any let's revisit and let's see where you are, and let's spend first quarter kind of tweaking in this so now we can go into the math. No, they started right where they left off. And it left a lot of kids behind. And we're still trying to dig ourselves out of this academic hole. Yep, till this day. All right. That's my soapbox. I'm off. Okay. Social degree in that you remind me of my high school days. Oh, thanks. D and trig, is that good? I'm in high school. That's right on the cusp. You know, one more. There isn't any more. Yes, no problem. It's really it really is. They're thinking that they're doing something good, but all they're doing is just pushing the kids further and further behind. That's all they're doing. All right, so before we skedaddle, I want to do a couple problems that people may see as a geometry extravaganza. Just want to do about 4 and just want to see it, and then we can finish up. Okay? I know, right? I was like, I don't have any more. Do I do college trig? Because I need help. To an extent, it all depends on what your college trig is. Okay? To an extent. Because there's some stuff that I'm okay with, and there's some stuff I'm just like, ugh, can't. All right, so let's take a look. So we have, I know it's really small, and I'm going to try to read it to you. Ready? Once upon a time, there was a circle P that's being shown. So points W, X, R, where's the X? Are on the circle. There is no X. That must be a Y. See, already finding typos and stuff. Okay, so W, Y, R, Z are on the circle. The measure of W, R, Z. So the measure of this arc right here is 200 degrees. The measured angle WYZ is 4x plus 20. And the measure of YWZ, so this angle here, is equal to the measure of WZY, which is this angle here. So these two angles are the same. So they want to know what the value of x is. How would I find the value of x? Do I post videos like this on YouTube? Yes, I do. So I use them for math. You can use these for math? Yes, you can. I know. Last night I was trying to post, and I don't know, sometimes TikTok is just very weird at certain times of night. Okay? So, how can I use AI? Why not? Take a picture of it. Use AI if you can. All right, so let's think about this. First off, this angle WYZ, that's what's called an inscribed angle. Okay? Inscribed angles, the best thing I can describe it is half the measure of its arc. Okay? So if I'm looking at half the measure of this arc, it will equal that angle. So let's take a slide shift. Okay, so if I take half of the measure of this arc, it will give me the measure of this angle. So half of 200, last time I checked, is 100, right? So I have 4x plus 20 is going to equal 100 because I took half of the 200. Okay, so we can find the measure of angles, okay, if you want to. So I know it looks like, oh, well, that's 180 degrees. No, because from W to Z, it's not going through the center of the circle. In order for it to be 180, that means it's going straight through the center of the circle. All right. So it's not half of the circle. So it's the definition of what a inscribed angle is. Okay. So from here, we're going to subtract 20. And who said it? Okay. Loyal Lewis has mentioned. So we got 4x is equal to 80. So if I divide both sides by 4, I'm writing on my tape right now. We have x is equal to 20. So that's going to be option A. Okay, so that's what the value of x is. But then it asks, and the measure of WZY, so WZY is going to equal what? So it's asking about this angle, not this one. If that's going to be 100, right? Remember, it was half the angle measure. And these two are exactly the same. Okay, so this is 100. That means these two have to add up to what? Not 50, not 80. It's okay. There we go. Okay, DMX, yes. Jasmine, yes. Yes. Pog, yes. Michael, yes. John, yes. Sorry, this is going crazy. Okay, not one. Well, it equals 180. So that will be 40. Yes, Danielle. Yes, headphones. Okay, take half of that, Terminator. Okay, take half of that. How is it 40? So let's think. A triangle, no matter what kind of triangle it is, the measure or the sum of its angles is always 180 degrees. Regardless if it's an acute triangle, a obtuse triangle, a right triangle, a scalene triangle, no matter what type of triangle it is, it always, the sum of its angles equals 180. If we figured that this angle, y, remember, it's half of its arc. The arc was 200, so we know that that's 100. So that means in order for the sum of my angles to equal 180, this has to equal 40 as well as this. Because 40 plus 40 gives me 80. And 80 plus 100 gives me 180. Okay. Yes. So since there's two, so we're good now. Okay. So that means the measure of that angle is 40. Okay. How do we know it's half the arc? Because of the type of angle it is. So we're looking at this angle right here. Anytime you have an angle whose vertex is on the circle and its other ends or vertices are on the circle, we have what's called an inscribed triangle. Okay, let me see if I have something on inscribed triangles. We do. Okay. All right. See, isn't this great when I have notes? So, central angles, when the vertex is on the center of the circle, the measure of that angle is exactly the measure of its arc. So this angle was 110, and its arc is going to be 110. That's only if the vertex of that angle is on the center of the circle. Now, if your vertex is on the circle, okay, this is the inscribed angle. That means half of the arc is equal to that inscribed angle. Okay? Or if you want to double the inscribed angle, it will equal the measure of its arc. So for this problem, how they got an answer of 45 degrees, first we have that central angle. So that's telling me that this arc is going to be 90 degrees because the central angle was 90 degrees. This was 90 degrees. So after we did that, now we're looking at the inscribed angle. So half of 90 will give us 45. Okay. What do I call these type of notes? These are Audrey's notes. Okay. This notebook I actually designed. I got tired of my students not having notes when they come to tutoring sessions, and I wanted to make something nice and easy for them, especially for the parts where they can write their formulas. So anywhere that they can write the formulas, let's say the quadratic formula, here's the formula of it, and then right underneath it, they could write their steps down. So I also give them some space to like write their problems out on both sides of the equals, both sides of the pages. They can also do their graphing. They can pull out problems. And I'm actually selling my notes. Yeah. So you can actually get your own copy of Audrey's notes. And actually let me show you what is going on before we get to the next bits. So the cover of Audrey's notes, I'm working on actually making the book. Right now it's digitized and it's available on my website. But the best thing that I like about Audrey's notes is everyone has a QR code. If you scan that QR code, it will take you directly to the live that I did that deals with these exact notes. So, yes. Okay. So like you can always like just go scan it and it'll take you right to the notes. Some of the earlier ones, especially in book 1, some of them I did not have because TikTok gets rid of their earlier notes after like 30 days. So there's a couple of them that's missing. But for the majority of them, if you just scan the QR code, it will take you directly to everything. Yep. So if you go to my website, the page will look something like this. And then I have like the prices for book 1, book 2, book 3, which is this book. This will be done in probably tomorrow. And then you have like your 2 book bundles and your 3 book bundles. So if you want to get the Audrey's notes, you can basically catch it, follow along. You can do that. But if you want the book itself, you can go to my website as well. I feel like I'm missing a whole conversation. Let's see. So I think I have okay. All right. See you, Jasmine. Geometry teacher. Sure. Yeah, you can definitely order the books. You can order the books, which will be blank. So there's 3 different covers. As soon as I can organize myself a little better. Okay. So you have this cover, you have this cover, and you have, I finally got it today, this cover. Okay, so again, it gives you like all the resources, it gives you the factor charts, it gives you the rules of integers, subtraction, multiplying, and dividing. And if anything, you have like the most famous words or for each terminology: addition, subtraction, multiplication, division, equals, and inequalities, as well as the order of operations, properties of exponents, linear and the quadratics, equations. Then we have area of perimeters that's going to be added. We have volume. We have surface area, area of a sector, arc length. Also the equation of a circle. And then in addition to the unit circle, we have Pythagorean's theorem, we have SOHCAHTOA, and some of the trig identities that's in there. And then I also have what's called brain breaks. So I give kids like a couple brain breaks, but it's 100 pages. Okay, we have the dots on one side, we have the grid on the other side. And usually, because I write rather large, you could probably like have like one book will cover per quarter. Okay, if you do like a lot of notes, and then the kids can actually, if you give them handouts, they can cut it and paste it, put their notes onto it, and they'll be able to take it and run with it. All right, so yeah, that's those. And then I also have for younger kids. Okay, so if we have any that's in 4th and 6th grade and they just need bigger sizes, I did a little bit larger for my 4th and 6th graders so they can practice keeping everything in line. They also have their factor sheet because kids nowadays don't know how to read a multiplication table. Trust me, the struggle is real. Then also the breakdown of fractions, the definition, the parts, examples, both visually and also mathematically. A couple of these for you to do activities with them. Those would be great for during the summer. And then also going from percent to decimals and decimals to percents, vice versa. We have fractions operations, for addition, subtractions over here, multiplication, division. Then we also deal with decimals and place values. Notice I do it in color. Okay, very interactive, very bright. Really keeps the kids' eyes going, as well as rounding and long division, the step by step. Then we have the conversion charts, again with the order of operations and properties of exponents. And then we have our volume and surface area, and then writing and solving equations, as well as the rules of integers. So, and then of course, I will have it all step by step. So it's a little bit smaller, as you can tell, it's a little shorter because it's smaller kids. Gotta deal with the smaller kids, right? All right. Can you do SOHCAHTOA? Okay. Please order that. Sine, cosine, tangent. As an adult, just to refresh my memory, I can't be the parent that can't help with homework. I feel you. And that's the main reason why I'm here. That's the main exact reason. I'm 11. Is that bad? To learn math and when I get into construction. That's fine. No, that's not bad. The fact that you want to learn speaks volumes. Okay, the fact that you want to basically get everything done, that speaks volumes. All right, so getting a little bit of the requests. Let's see. Let's see if I can help you guys out. Let's go. Now, are we doing the inverse of sine, cosine, tangent? Okay, we can do this. Let me just try to get some math problems ready for you guys. Because I wasn't prepared for the SOHCAHTOA. I wasn't. I don't know why I wasn't. I don't know. You would think. Oh, sugar. What's going on here? All right. So. All right. Because I know I did them. All right, let's try this. All right, so here we go. So let's go with a regular, nice little triangle here. Try and keep it right. And then this is the reason why I have the dots. Makes my graph so much nicer. All right, so let's say, I don't know if we have to go that far into it. So let's say that I have, okay, this will be a 3. Everyone knows the 3, 4, 5 triangle. And let's say that this is my theta. All right, so when it comes to basic trig, we have our so, we have our ka, and we have our toa. Okay, so for your so, that means sine. Okay, so the sine is always your opposite over your hypotenuse. So right now we're just trying to figure out its placements. So if this is my theta, it's always based on the angle that is given. Okay, so they're going to give us an angle. So since this, I'm just going to put it over here. So since this is my angle, opposite is always directly across. So this is opposite. Adjacent means next to. Okay, adjacent means next to. So sometimes it's easier for me to find the opposite and then the side that's directly across from that 90-degree angle, that's your hypotenuse. So finding the opposite and the hypotenuse, it's easy to find the adjacent. Okay, so sometimes people like to work it that way. So we want to find the ratios that's going to satisfy our sine, our cosine, and our tangent. So sine is always opposite, which is 4, over your hypotenuse, which is 5. So your ratio is 4 over 5. Okay. So right now, it looks like a little intro for trig. Okay. So now, we got a cosine. Cosine is your adjacent over your hypotenuse. So your adjacent, that's going to be 3 over 5. And then for your tangent, it's going to be opposite over your adjacent. Easier way is just take your numerators from each of the sine and cosine. So opposite is 4. And then your adjacent is 3. Okay. Do I need to speed this up? Meaning, am I looking for angle measures? What are we doing? Okay. Yours goes really fast? Okay, no. All right. Gotcha. Now, are we doing the inverses? I don't know. Okay. Yes. Okay. Now, so that's your sine, that's your cosine, that's your tangent. So if we're doing the inverse, now the inverse, we're basically going to be flipping the ratios. So we have what's called a cosecant. We have what's called a secant and a cotangent. Now, the cosecant, remember, the S and the C's are always paired up. It's never S with S or C with C. It's always going to be your S with your C and C with your S. Okay? Cotangent, cotangent, that's just basic opposites. So the ratios for that is going to be flipped. Is your hypotenuse over the opposite. This will be your hypotenuse over the adjacent. And this will be your adjacent over opposite. Okay, speed is just right. Okay. So all you have to do is flip them around. Okay. So all we have to do is flip it around. So if opposite is 4 and your hypotenuse is 5, that means it's going to be 5 over 4. If it's a hypotenuse over adjacent, it will be your 5 over 3. Good. Yes, 3 over 4. Thank you. Okay, so once you find the original, the sine, the cosine, and tangent, knowing what their inverses are, you're just flipping the ratios around. Okay, well, good, thank you. All right. Use determinant if say per cosine. Yes. So that's why you always want to say So your S always pairs up with your C. And your C always pairs up with your S. It's never SS or CC. Okay. All right. Now, how to find if you ever get you're missing a side. You're going to use Pythagorean theorem to find that missing side. And then you can go into your SOHCAHTOA. All right, not a problem. All right, so let's figure one out. Let's do... I know I feel like I make my right triangles exactly the same. But here we are. Why not? Or maybe it doesn't have to be that ridiculously large. Okay. So here's my 90-degree angle. So let's say that this is 5 inches. And this is, let's say 12 inches. Okay. We need to know what our hypotenuse is. Okay. Okay, we don't have this in GED. Who says you don't have this in GED? Yeah, they always love to sneak one of those things in there. Trig is in GED. Okay. All right. Yeah, anything with a right triangle or volume, they definitely have in all assessments. GED, ACCUPLACER, TEAS tests, ASVAB. Oh yeah, ASVAB, definitely. Okay. All right. So, since we need to find the length of the side, we got to figure out SOHCAHTOA. There you are, C4. Okay. Okay. Circumference, I think I can do tomorrow. I can do circumference and area. Okay. So now for here, it is good. C4, good. Ooh, how do you pronounce it? Nado, is it Nadazi? Nadazi? Or am I completely butchering it? I'm so sorry. Okay. A square plus b squared equals c squared. Yes, good. So we are going to be doing Pythagorean's theorem. So I'm going to take that down here. So I have my 5 squared plus 12 squared equals my unknown squared. So here we have 25 plus my 144 equals my hypotenuse squared. So that gives me 9. So this is 169 is equal to c squared. Then I have to take the square root. Remember, squares and square roots are opposites of each other, so they almost cancel out. And the square root of 169, if you ever get stuck, I go right here to 169. My thing is in blue, and I notice I have 2 of the same numbers. So that's telling me that square root of 169 is a perfect square root, which gives me an answer of 13. I just need one of those 13s. Now, normally we would say it's going to be plus or minus 13. But since we are doing a measurement of a triangle, it's just going to be positive 13. Okay, we have to get into the habit, especially later on, when you're coming out of a square root, you're dealing with positives and negative, because I can say negative 13 times negative 13, that will give me a positive 169, as well as 13 times 13. Okay, but since we're talking about length, this is going to be 13. Let me make up here my theta. Okay, that angle that we're trying to look for. So we have our our ka, and our toa. Okay, so if we're using theta, the side opposite is going to be this side with the 5. The side opposite that 90-degree angle, that's my hypotenuse. That means the side that's next to theta, that's our adjacent side. I like to label. I'm one of those people. Okay? Yes, SOHCAHTOA. All right, so what are my ratios? Okay, good. Mateo, good. So, how do you know which one's opposite? It's all based off of where is your angle, your theta. If they give you that angle measure, sometimes it's up here, sometimes it's down here. So it's all based off of this angle. Okay, so this is up here, that means across from it, that's your opposite. The 90-degree across from that, that's always going to be your hypotenuse. That's never going to change. And then the other side, that's going to be your adjacent. All right, so for we're saying opposite, which is 5, over your hypotenuse, which is 13. Your COA is your cosine, which is your adjacent, which is next to, over your hypotenuse. So that is your 12 over 13. And your tangent is your opposite, which is 5, over the adjacent, which is 12. Okay. Can it be used in physics? Yes. Most def. Okay. Alright. Yeah, so if you know anyone that's thinking about maybe they're currently taking this in class or thinking about doing the ASVAB or GED and they need some assistance, you can go ahead and share it. Lex, what's wrong? What does the 90-degree angle do again? The side that's directly across from the 90-degree angle is your hypotenuse. That will be your longest side, Lex. Okay, so you didn't take it yet. Okay. Okay. Well, welcome in, Carol. Okay. So, we have our sine, we have our cosine, we have our tangent. So now if I'm doing the inverse, remember, S doesn't go with S. S goes with C. So you have the cosecant. And remember, the cosecant is your hypotenuse over opposite. It's H-O, ho. Then your C, what goes opposite the C is the S. So that's secant. And all we're doing is flipping this ratio. So we have our hypotenuse over our adjacent. That's supposed to be an A. I know it looks like an H. Now for my tangent, the inverse is cotangent. And cotangent will be your adjacent over the opposite. Okay. Yes, math. Oh, you just missed out on the 30, 60, 90. But that's all right. If you ever want to watch the replay, if TikTok will let me, I have all my replays on my YouTube channel. It's written TikTok Live. I know, I was very inventive with the name. So if you go to Audrey Codner ACG Math Tutoring, you can see all my lives that I've consumed since February 5th. Okay. All right. So now let's flip them. So this one will be 13 over 5. This one would be 13 over 12. I suppose this is 12 over 5. Okay. How are you guys feeling? Okay, so that deals with the ratio of the sides. Okay. I'll see it online. Okay. Feeling tangent? Like you're kind of there, but you're still going off into the distance? All right. So, so do we need to find the angle? To find the measure of the angles? Yes? Okay, we can. Yes. All right. I just want to know how far into trig I need to get to, especially for tonight. All right. Okay. So if I want to find the measure, so you're probably going to need, I want to say you're going to need your calculator, and your calculator needs to be in degree mode. You will surely get an answer. But if you don't see, what I mean by that is like I have DEG, so that's in degree mode. And then they have this other one, let's call RAD. And that's radian modes. And we don't want to be in radian. We want to be in degree mode. Okay, so you always, I would show you my phone, but I'm on my phone. So if I go, gotta get myself some batteries. But if I go to my mode, you notice right here, it has radian and it has degrees. Make sure degree is highlighted. If you're using your phone, you should see the word RAD. That means you are in degree mode because you have to push the button to go back into radian mode. All right. So if we are looking for, let's say, let me go over here. So let's say, let me change up my, okay, so here's our 90 degrees. Let's say that this is 40 feet. This is 28 feet. And we're looking at the angle measure made to the ground. They always have word problems like this. Like you have a 40-foot building. There's like a 28 feet away from the building. What is the angle, as they like to say, the angle of elevation, okay, to the top of the tower? So we're trying to find the angle. So in order for us to do this, we need to figure out which of those signs, and when I say sign, I mean I have my sine, I have my cosine, and I have my tangent. Okay? Remember, your sine is your opposite over hypotenuse. Your cosine is adjacent over hypotenuse. And your tangent is opposite over adjacent. Okay? What are they not giving us? Good, Pog. Okay. Okay. All right. What does tangent do? So tangent is basically your opposite over adjacent because they're not giving us the hypotenuse. So using tangent will be the best bet. So I'm looking at the tangent of theta. And remember, tangent is your opposite. This is our opposite over adjacent. So it's going to be 40 over 28. Okay, see what happened. Yes. Hey, Omar. Okay. So it's your opposite over adjacent. But we want to figure out what the measure of theta is. So this is the setup. But in order for me to get theta by itself, I have to do the inverse of tangent. So it's going to look like this. I have my theta. Then I will do the tangent of -1, that's your inverse, of 40 divided by 28. So on your calculator, if you notice where you have sine, cosine, and tangent, above for me in yellow are those inverse signs. The only way I can get my yellow options is if I hit the second button. So if I hit second and tan, then I got my tan with the -1 as an exponent. That means I got my inverse. So all I have to do from here is type in 40 divided by 28. All right. And if I want to round, most teachers want you to round either to the 100th or the 1000th position. Right now, we can round to the 100th. And the 100th is the second decimal place. So that means I need to look in the 1000th to make a decision. So if it's 5 and above, which it is, 7 is above 5. So when I say 5 and above, I mean 5, like 5, 6, 7, 8, 9. Okay? If it's 5 and above, which it is, I'm going to give it a shove. Meaning I'm going to add 1 to the previous spot. So the previous spot is 0. So I'm going to add 1 to 0, which gives me 1. So my theta, which is my measure, is going to be 55.01 degrees. Because remember, theta is your angle measure. So 55.01. Good. Now, radians, good question, star. When you are finding an angle, you're going to keep it in degree mode. Okay? Degree mode, if you keep it in your calculator, is not going to mess up any simple operations or anything. Radians, that's what happens when you hit your, let me see if I find it. That's what happens when you start hitting what's called the unit circle. Notice 30 degrees, the equivalent in radians is pi over 6. So that's when we start dealing with pi. Okay, 45 degrees is equivalent to pi over 4. 60 degrees is equivalent to pi over 3. 90 degrees equivalent to pi over 2. So when you're dealing with the pi's, you're dealing with radians. 180 degrees is pi. Okay, so going all the way around and back again, that's a full 360. 360 degrees is equivalent to 2 pi. Okay, so that's when you know. When they're asking for degrees, leave it in degrees. If they start going into unit circle function, that's when you're going to switch it to radians. Okay, so that usually doesn't happen until like pre-calc. Y was opposite on base on the last, but not one here. Y was opposites. Okay. Oh, okay. Because if you notice, my theta was up top, whereas the other one, my theta was down here. It's all based on where theta is. Okay, you always look for the angle measure. So if they're saying opposite, you find theta, boom, not the 90-degree angle, the theta, okay, that Greek symbol right there. Opposite is going to be the side that's directly opposite that angle. Okay, so that's called your reference angle. So whereas before it was up here and opposite that theta is down here. Okay, not a problem. No, this is the perfect time to ask questions. Good question, Lex. Okay, do you see it now, Lex? Danny! How are you? All right. Okay, so something's telling me, what do I need to do tomorrow? You find angle of last problem. Find the angle of this problem? I mean, we can. I'm all right. I learned something today. Good. Okay, good. All right. So if we want to find what theta is for this one, we got options. Okay. So since we know all three sides, we could find this by using sine, we can find it by using cosine, and we can find it by using tangent. Hell, we can find it all three ways. Why not? All right, so this is our theta. So if I want to, I can use sine. So if I go to sine of theta, sine is our opposite, which is 5, over my hypotenuse, which is 13. If I want to, I can also, all these red, I can also do cosine. We're going to solve it separately, but I just want to set everything up. So like we said, cosine is going to be 12 of 13. Okay. Let's work on sine first. So I want to get, there we go. I want to get my theta by itself. So this is when I got my theta, and I do my inverse sine. Oops. Of 5/13. So this is when that handy dandy calculator, comes into play. So we have my second sine, and then we have 5 divided by 13, and we hit enter. So it looks like 22.60 what, if we're rounding to the 100th. C4's got me with 22.62. Okay, good. Okay, so we got 62, good. 22.62, excellent. So do not forget the degree symbol, okay? If I tried to do it with cosine, here's my theta, and then I'm doing the inverse of cosine, and I get 12/13. So if we have inverse, and we have 12/13. Got the same answer. Even C4 said that earlier. Okay? So it's exactly the same. What do you think is going to happen with tangent? What do you think is going to happen with tangent? It's going to be the same, right? All right. So we got our tangent, a theta, equals, now my tangent, remember, that's your opposite, which is 5, over my adjacent, which is 12. So we have our inverse of tangent, 5/12. And it gives me, I'm going to do it approximate. That's what that wave is for. Oops. I think we got it right there. Second tan. So this was 5/12. And you get the same exact. Okay? So, okay? So this, hopefully it shows you that it doesn't matter which one you choose, you're going to get the same answer. That's the main point that I have for all of this. Okay, so it doesn't matter if you pick sine or cosine or tangent. When you need to figure out your theta, just make a decision. Okay, just make that decision. Alrighty. Mystical, why are you crying? Why are you crying? Good, bundles of blessing. Good. I was like, it's math. I'm like, there's no escaping it, mothers. There's no escaping it. Sometimes you just gotta face stuff head on. All right? And it's funny, I'm not even sure if the person that asked for this, if he's still here. Thank you so much for the stuff. So this is what I tried to do. You know, I know it's tough because sometimes it jumps from one thing to the next. I usually like to just stick with one thing. But lately, since a lot of people are trying to get their final exams and see if I can help out in that retrospect as well. But for the most part, it's just like when you're here, we're just going to take things step by step. Now, I'm not sure if I can, because I don't know. I don't think I can on this platform. Because I was going to, on your YouTube, do you got trig? There are some trig, not a whole lot. Because, you know, I just started in February and been doing a lot of, you know, ASVAB stuff and, what is it, GED and ACCUPLACER, and I've just been doing a lot of that stuff. But, hey, you can always take a look. You never know. You might find something that you're looking for. So, if anything, let me just do this last bit. So, again, if you can, go ahead, free subscription, YouTube channel. I'm not the type of person that will harass you. I do not like asking for emails unless it's something that is vital that we both need to deal with. But if you want to, you can subscribe to my YouTube channel. And anything that comes up, I like to do some shorts on some things, as well as I plug those on here on TikTok. But for the most part, just go to Audrey Codner, ACG Math Tutoring, to subscribe to the YouTube channel. My schedule, I do have on my YouTube channel, my TikTok, which Monday through Thursday, I'm on at 9:30 p.m. Eastern Standard Time. Friday at 1 p.m. Eastern Standard Time, and Saturday and Sundays is 8:30 p.m. Eastern Standard Time. Okay, because I'm in Maryland, so there we go. Haven't seen this in my early 70s, 74s. All right, there you go, bringing it back. All right, but if you do need a tutor, you're getting close to your finals, you're getting close to your exams, and you're like, I just need some help. If you're thinking about taking the ASVAB and you really want to, get to a certain area, and you haven't seen algebra since you were a fetus, hey, I'm willing to help. I'm willing to break those concepts down. Actually, last week I had 3 different people. 2 people I saw like once, and another person I've seen like 4 or 5 sessions, and they all passed their ASVAB. And my recent in person, she's in Florida, and she did her end of course exam, and she didn't just pass it, like she just blew it out of the water. So I don't want to say and tweet my own horn like toot toot, but I can help you break down concepts that you will understand so you can do well on these assessments. You have to understand that when you take any kind of like standardized assessment, it's different from taking a test in your regular classrooms. Okay, you're looking at the orders, you're looking at the answers, and you're doing process elimination. That's how you do well on these assessments. If you can understand the basics, like say if I'm multiplying 45 times 2, okay, I know the 5 times 2 is going to give me a 0. That means I need to take a look at my answer choices to see which one ends in 0. If you see 1 and that's all you have to do, boom, that's your answer. Mark it, move on. Okay? They want people to go into the military. They don't want people not to be able to go. They want people to be able to move forward academically, but they're going to make you jump through some hoops in order to get that achievement taken care of. Okay? I know, right? Cool. Right? And I know it's hard. And that's one of the other things that I wanted to do a poll, but for some reason I can't find it on my computer right now. I am planning on starting a curriculum, especially designed for people that are thinking about going back to school and they just need a refresher. So like for those that just like, look, I need for someone to start all the way in the beginning, like adding, subtracting, multiplying, dividing, positive and negative numbers, decimals, fractions. So then we can go to percents, and then we can go to ratios. And after ratios, now we can talk about linear equations and solving one-step equations and two-step and multi-step and distributive property, and then slowly go into graphing and advancing into like possibly system of equations, and just get to a certain point that you can go to a community college, take their ACCUPLACER, and skip a couple of those classes that you are paying money for, but you're not getting accreditation for. The only time you start getting accreditation is when you're in college algebra. So if I can set up a course to help those that hasn't been in schools again, since you were a zygote, there we go. That's even further back than a fetus. I'm planning on starting that June the 1st. So if you're interested, just type the word yes in the chat. And then I can we'll figure out a way to contact each other and take on. Did a poll on her last week. Ask her. Okay, will do. Thank you, Michael. Stop aging us. I'm not just aging you. I'm aging myself too. Like, shoot, I'm 52, soon to be 53. I'm just practicing saying I'm 53 because before you know it, September will be right back here again. Jesus, can't believe it. But yeah, I think because she's on her TikTok live, and I'm still trying to figure out how to do my TikTok live. I know I sound younger. I know it's me not having kids. It just, I guess that's what it is. I don't know. It's all kind of hip and happening. So yes, right. So if you are interested in that, go ahead. Even though you probably said it yesterday's live, because I did present the idea, I want to be able to see it on all the responses, because then I can really get a good sound idea and see who's repeating and see who's new, because there's a lot of people that's not new. So if it sounds like something that does interest you, that hey, I really want to get this, because when you're in the community college or you're going back to school, regardless if it's a community college or a regular college, it doesn't matter. The pace is going to be huge. Everyone just thinks that, oh yeah, I'm just going to sign up and they're just going to take their time. No, they're not. It's not like regular school. Like when you were in high school, you were given like 2 weeks on one concept. That's not it. You're probably going to get 2 or 3 concepts per night. And on top of it, given like 20 something problems to do. And then you're like, I'm overwhelmed automatically, because you haven't seen this in so long. So that's why I want to do something as like a precursor or a prerequisite, so it'll help with that transition and it'll get you further along. Okay. All right. Cool. Okay. Thank you so much for the taps. Thank you so much for your time and attention, especially on a Sunday night. I greatly appreciate like each and every one of you, even those that are just listening and just like, look, lady, you confused the living daylights out of me. And I don't know if I will ever see you ever again. But if anything, don't give up, no matter what. I know things are going to be challenging. I know there's going to be times you're going to be like, I give up. This is way too hard. And it's hard because you have questions and you are convincing yourself that you know what's going on. That's what we do as human beings. We will try to figure something out. That's what we do. And we'll convince ourselves to say, yeah, that's the right answer, and it'll be completely wrong. Okay? So I'm always willing to be here to give you guys some tips and tricks and be able to take it and run with it. Okay? But you can meet me here tomorrow night, 9:30. I'll be here with something with math. And the way this is looking like, I think book 3 might be on the full price block by Wednesday. So, not a problem. Thank you, Bundles. I appreciate you. And for all you guys that are mothers or women, hey, I appreciate you too. I'm hoping that the appreciation will continue on and not just happening on one day a year. We just need to kind of work with each other so we can get this thing called life back on track. Okay. All right, guys. So if you ever need me, go ahead and DM me. Please do not hesitate. You know, you can ask whatever question you want. Just keep it culture. And if you have any questions or concerns or anything, just go ahead and reach out. All right. All right. Thank you so much for all the likes. Look at this. 25.2. Man, you guys are crazy. And I love that there's still 140 something people in here. My goodness. So if anything, yep. I'll see you guys tomorrow. And if you want to follow, that's why I keep forgetting. How can I forget? Okay, take a quick screenshot. If these are the people, if you're thinking about doing nursing, a blessed RN is a perfect person to go through. She does her doses calculations with very little math, not too much into it. Then we have T's, ASVAB, GED math, similar to myself, but we have Miss Taylor at Impact Math 19. I know she goes live Monday through Thursday, possibly Friday. No, she does Fridays too, at 1 p.m. Central Time, which is 2 p.m. Eastern Time. Then you have chemistry tutor if you're looking for Professor TK. She's great. She only goes live on Tuesdays and Thursdays at 10 a.m. But she also has some videos showing like how she does interactions and chemical bonds and all that. And then my friend Lynette with Abacus Math, Learning with Lynette, she's basically taking the abacus and she's transforming it. Like she's totally modernizing it. It's great for, especially now the summer is coming up and you want to do something with your little kiddos to help them add, subtract, multiply, and divide. That she can teach them how to break down these concepts. She has books on TikTok. So everything is, this is a great person for you, especially this time of year. All right. Okay. I did my job. I did what I need to do. Now I'm about to go and pass out. All right. Have a great night, guys, and I'll see you tomorrow night. Take care.